Yo, what's up? For this topic, we'll be doing, we'll try looking at solving quadratics through factorizing. And for a lot of people's, they get nervous when they're doing this because they think like they're gonna have to like guess and whatever. But there's actually a way to do it without guessing, a foolproof way. So let's just look at that. So let's do an example question. So 6x squared plus 11x minus 35 equals 0. Now, the method that you should look at when you're doing stuff like this is you would take the product of 6 and so you take the product of this coefficient and the constant here, and you try and find a pair of numbers that multiply to give that number and add up to give 11. So for example, 6 multiplied by minus 35 would be minus 210, right? So we got to try and find the factors of minus 210 that would add up to 11. So that would be, so you could have 2 and minus 105, or the other way around. You could also have 21 and 10, and a lot of other ones, but let's just stick to those for now. So as we can see, 21 and 10, we can do something with that to get 11, right? So 21 times minus 10 is the pair of factors that would give minus 210. If we add them together, they'd also give 11, positive 11. So now we can do this, look. So we can rewrite plus 11x as this. Sorry about that. Okay. So you haven't really changed the equation much, because if you simplify minus 10x plus 21x, that should still give you 11x. You've just put it in a form that's like factorizable. So now we take out the highest common factors between this part here and this part. So let's do that. So highest common factor between 6x squared minus 10x would be 2x. So you factor out the 2x. And then for 21x minus 35, that should also be 7, I think. Yeah. So 3x minus 5 equals 0. And now 3x minus 5 and 3x minus 5, you can see that these two expressions are the same. So you can just put it in this form. You can now say 2x plus 7, 3x minus 5 equals 0. And now from there you can solve for x. So you could either have x equals minus 7 over 2, or x equals 5 over 3. Because, yeah, so you just bring, like you drop the 2x plus 7, and then you solve for 3x minus 5, or you do it the other way around, and you should get these two answers. So let's do another example. Let's do something more simple. Let's maybe x squared plus 5x minus 24 equals 0. So just try to do this on your own, and then, yeah. Okay, so what you would do here is the same thing. 1 times minus 24 is minus 24, because the coefficient of x squared right here is 1, right? So now the factors of minus 24 that add up to 5 would be 3 and minus 8. No, minus, yeah, minus 3 and 8. So now we just reformat it. And then you can factor it out. So highest common factor between x squared and minus 3x would be x. So x minus 3. And then 8x minus 24, that should be 8. So 8 goes into minus 24 3 times. Okay, so equals 0. And then you just collect the coefficient here and here, x plus 8, and x minus 3. Just put brackets around here. Okay, now you can solve for this to get x equals minus 8 or x equals 3. So, right, let's move on to the next subtopic, solving quadratic inequalities. So this is kind of confusing. I know I was confused when I did it, but let's just get into it. So I just want to remind you the shape of the quadratic graph, right? So if you had a minus x squared, so y equals minus x squared, the shape of the graph would be sort of like a frowning face. It would be like that. But if you had a x squared graph, then the graph would be like this, smiling face. So yeah, just remember that when you're doing this, because it's kind of important. You'll see why later. Let's do an example. Let's solve the quadratic inequality x squared minus 3x. That's a bit untidy. Minus 3x minus 4 is greater than or equal to 0. So this does look kind of confusing, but it's actually pretty easy once you see how to do it. So if we were to represent this visually, it would be something like this, I think. Well, it would be something like this. I don't know exactly where it intercepts, but it's a smiling face with some of it underneath the x-axis. So that's all that matters right now. So what you would do is x squared minus 3x minus 4 basically just represents a y value, right? Like you can say over here y equals x squared minus 3x minus 4. Now you want to see where y is greater than or equal to 0, basically. So where is y is greater than or equal to 0? It's basically in this area here, right? That's the only part of the graph where y is not less than 0. So there, you kind of have it there. Now, you'd want to try find the roots now of the graph, because that's where this y is greater than or equal to 0 starts. So the first step is to find the roots, and you can just use the quadratic equation for this or something. The roots would be x equals minus 1 and x equals 4, right? Roots. So wherever x is less than or equal to minus 1, y is also greater than or equal to 0, right? So oops, less than. Basically this area here, y is greater than or equal to 0. And also this area here, where x is greater than 4, greater than or equal to 4. So that's like how you must think about it, right? So think of this whole equation, this whole like expression here as y, and then just check where, like what it's asking you. It's asking you to check where, for what values of x is y greater than or equal to 0, which is all this area here and all this area here. Let's do another example. Let's do a negative coefficient now for x squared. So let's do minus x squared plus x plus 6 is greater than 0. So we can see it's a negative coefficient. Let's just try and represent that visually. It would be something like this, I think. Yeah. So now we gotta check what it's asking us. It's asking us where is minus x squared plus x plus 6 greater than 0 for which values of x. So that's just like, so we can kind of imagine it in our heads. We can say minus x squared plus x plus 6. Okay. So for which values of y, like where is y greater than 0, right? It's greater than 0 in this area over here. In this area bounded by the two roots. So now we just gotta find the value, the x value of the two roots. And to do that, we can use the quadratic equation, because that's kind of easy. So minus 1 plus square root of 1 minus 4. So x is equal to minus 2, and x is equal to 3. Let's just write that down. So those are the roots. Now, for which values of x are y is y greater than 0? So in between minus 1 and 3. So in order to represent that with inequalities, we would just say x is greater than minus 1 and less than 3, right? So we can say x greater than minus 1 and less than 3. So this should be your answer for this question here. Let's do one last example for the inequalities. Let's do a kind of more difficult one. 24 is greater than 11. That's kind of, let me perfect that greater than sign. Is greater than 11x minus x squared. So we notice they're not on the same side, so let's just try and bring all the whole quadratic to the same side, right? So we subtract by 24. 0 is greater than minus x squared plus 11x minus 24. And I just wanted to show you something. Say, for example, you don't really like working with negative coefficients, like in inequalities. You can always kind of alter that by multiplying everything by minus 1. But you must be careful, because in an inequality, when you multiply by minus 1, you flip the inequality sign around. So if I wanted to put this into x squared minus 11x plus 24, I'd have to flip this around. So I'd have to say 0 is less than x squared minus 11x plus 24. So just keep note of that and make sure you don't like do a silly error with the like forgetting to flip or something. So let's try and represent that visually. Although, like in a test or something, I don't think you have to represent it visually, but we're just doing this now to learn or whatever. So it would look something like this, I think. Cool. So now we got to find the values of x where the quadratic basically gives a y that's greater than 0. So this area here basically. So we got to find the values of x for that. So the first step is to find the roots. So I'll just use the quadratic equation again. 11 plus 121 minus 4, 24. So x is equal to 8. And x is also equal to 3. So those are our two roots. Okay, well, I clearly drew this wrong. But yeah, so this would be a 3, and this would be an 8. So now we just gotta represent this using an inequality. So where, like, you have to say x is less than 3 and x is greater than 8, because that's where these regions belong to. So x is less, oops, x is less than 3, or x is greater than 8. That would satisfy this equation here, this inequality, sorry. So that's your final answer. Right, let's start off with the new subtopic in quadratics, completing the square. So in case any of you are new to this, what this basically means is, say we're given an expression, ax squared plus bx plus c. If we were to complete the square on this, we would basically be putting it in this form over here. We would be putting it in this form, a into x plus p squared plus q. So this does look intimidating, but all you're doing is like altering the equation, altering the expression, and factoring, like factorizing. So what we would do, let's do an example, right? So let's get x squared plus 6x, oops, plus 6x plus 1 is equal to 0. So we can see over here for this example here, for this general form, x plus p squared. So what we want to do is we'd want to like factorize the expression with x. So what we would do is we would do this, right? So we'd say x plus 3 squared. So that's the first step, because if you were to expand this, this would give you x squared plus 6x plus 9, right? Say x squared, x plus a squared, in case any of you forgot. This is just equal to x squared plus 2ax plus a squared. So you basically just doubling, you're doubling the products of these two together in the second number over here. So that's also what's happening here. You'd want to get a 6x, right? So that's why you would put 3 there. So you basically put half of the of the x term. So 6x, half of that is 3. Half of the coefficient is 3, so you say x plus 3 squared. But now this is also going to give us kind of an unwanted value, because if you expand this, you're going to get x squared plus 6x and plus 9 as well, but we don't want that in here. That's not accounted for. So we can now negate that by saying minus 9, and then we just put the plus 1 over here. Plus 1 equals 0. And now we just simplify. So the final answer would be x plus 3 squared minus 8 is equal to 0. So this is now, you've completed the square on this expression, on this equation rather. And if you want to, you can solve for x later on. Like, this is also a good way to like solve for x. This is actually where the quadratic equation is derived from. It's like completing the square on this general form. That's how the quadratic equation is derived, and I'll show you that later. So let's do another example. Let's do x squared minus 3x plus 1 equals 0. So we do the same thing over here. We took the half of the coefficient here and put it in this square brackets thing. So we'd also do that here. So we'd say x minus, and then half of minus 3 is minus 3 over 2. So minus 3 over 2 squared. This would expand to give us x squared minus 3 over 2x. Yeah, minus 3x plus 9 over 4. So that's what this would expand to give us. And we don't want the 9 over 4 there, because as I said earlier here, it's not accounted for. So you just say minus 9 over 4. So that once, like, if you were to expand this, the 9 over 4 is kind of negated. It's going to disappear because of this minus 9 over 4. And then you just put the plus 1 there. And now you just clean things up. So minus 9 over 4 plus 1 is minus 5 over 4, I think. There. So that's been completed the squared, or whatever you say. Yeah, so that's how you basically do it. Let's do an example now where you would have like a coefficient to the x squared. That's a bit more difficult. Let's do 4x squared plus 24x minus 9 is equal to 0. So in this case, you would do the same thing, except before you did all that, you would want to factor out the coefficient of x squared, right? Regardless of what it is, because you'd like want to make the coefficient to 1, right? So you'd want to do this. Plus 24x, so 24 over 4 is 6. Okay, minus 9 over 4 equals 0. So that's the first step. And now you do the same process all over again. So you do 4x plus 3 squared minus 9, because of the 3 constant getting squared is going to give you a 9, and you don't want that. So minus 9 over 4 equals 0. And then you just, as as earlier, you just simplify. So 4x plus 3 squared and minus 9 over 4. My small brain can't compute that, so let's just use my calculator. Okay, minus 45 over 4 equals 0. And now last step to simplifying would obviously just be multiplying this 4 to this term here and this term here. So you get 4x plus 3 squared minus 45 equals 0. So you can see how this has been basically put into this form. So like the A is the 4, the Q is the minus 45, and the P is the plus 3. So that's basically what this form means. If you see it in tests or whatever, sometimes they ask you to complete the square on the quadratic. So that's basically all there is to it. We'll do some examples more later on. So this is the equation that we completed the square on last time. Let's just try and solve for x. Solve for x from it. So we would just put the 45 on this side and then divide by 4. So let's say x plus 3 squared equals 45 over 4. And then you take the square root of that. So let's just and don't forget the plus minus, right? Because you can either have a minus or a positive solution when you do a square root on both sides. And then x is equal to minus 3 plus minus square root of 45 over 4. So we're seeing here that we can solve x from completing the square, right? So why don't we take this one step further and try solve for x in a more general view and try and derive the quadratic equation. So let's do that. So remember that form I showed you just now. So ax squared plus bx plus c equals 0. So this kind of has a lot of variables that we recognize from the quadratic equation, like minus b plus minus square root of b squared and whatever, and a and c. So let's change this around now so we can complete the square on it and then solve for x from there. And then that's basically how the quadratic equation is derived, right? You might have thought it's like a really long long process, but it's actually pretty simple. You just complete the square on this general form. So the first step would be to factor out the coefficients of the x squared. So a x squared plus b over a x plus c over a equals 0. And now we can just kind of divide both sides by a if we want to get rid of this annoying a coefficient here. So 0 over a is 0 and a over a is 1, so we can just put this as x squared plus b over a x plus c over a equals 0. And now from here we can start putting in this form here. So x, and then we half the coefficient of the x term. So x plus b over 2a, because half times b over a is 2a, b over 2a, and then squared. So now if you expand that, you should get x squared plus b over ax plus b squared over 4a squared. So because b over 2a altogether squared would give you b squared over 4a squared. So now you'd want to negate that as well. because that doesn't exist up here, right? So b squared minus b squared over 4a squared. And already we're starting to see some familiar patterns with the quadratic equation. So plus c over a equals 0. Now let's put these constants on one side. Let's take them to the right. So x plus b over 2a all together squared equals b squared over 4a squared minus c over a. Now we can square both sides. So square root of this would just give you x plus b over 2a. And then you square this side as well. So plus minus square root of all of that. So b squared over 4a squared minus c over a. And then let's just bring this to the side now. So x equals minus b over 2a plus minus square root of b squared, b squared over 4a squared and then you want to join these two fractions together, so you just cross multiply. So b squared times by a, that would be ab squared, and then minus c times by 4a squared, that would be minus 4a squared c. And then it's one single fraction now, 4a squared times by a, so 4a cubed. And now we can take out an a over here because we can factor out an a at the top, right? So we can get rid of that. So b squared minus 4ac all over 4a squared. And for the last step, now you just kind of put this into the form we now know. So in case, yeah, so x equals minus b all over 2a plus minus, and then it's like the law of indices. This just basically equals to square root of b squared minus 4ac over square root of 4a squared, right? So you can just say square root of b squared minus 4ac all over square root of 4a squared. And now for the finishing touches, you would just simplify the square fraction, the square root fraction. So you'd say minus b plus minus, and you can't really simplify square root of b squared minus 4ac. It's already in the simplest form. So you just say b squared minus 4ac. However, you can simplify the denominator, right? Square root of 4a squared is 2a. So, and now minus b over 2a, and this whole thing over 2a, there's the same denominator, so you can just join them up in one fraction now. So let's just do that. X equals blah, blah, blah. So that's how this formula exists, unfortunately. So yeah, that's it. Yeah. So sometimes you're gonna see some weird equations that then look really quadratic, like for example, x to the 4 minus 4x squared minus 21. Although it's not what we are familiar with. So what we would do to solve something like this is we would try and use like a substitution. So for example, we'd write an equation here. We could say y equals x squared. Let's not use y. Let's use something more exotic. Let's say r equals x squared. And now we can sub in that r to wherever we see x squared, right? So we can now say, well, x to the 4 is basically x squared squared, right? So we can say r squared minus 4 x squared, r, minus 21 equals 0. So that's how we would convert something intimidating like this into something more like more solvable. So now we can, well, we can just use the quadratic equation at this point. So r equals 4 plus minus which is equal to, let's just compute that in my calculator. So r is equal to 7, or r is equal to minus 3. So those are, that's the answer, but we're not really done yet, right? We need to find this in terms of x, not r. So if r is equal to 7, or r equals minus 3, then that basically means that because r is equal to x squared, right? So r equals 7 is basically saying r equals x squared, where 7 is x squared. So we can say 7 equals x squared. From this, we're getting this from this equation, by the way. So x is now equal to plus minus square root of 7. So that's two answers. And now we also need to consider this part over here. So we say minus 3 equals x squared, and square root, we square root both sides. So x equals square root of minus 3, and that's undefined. So we can just scratch that one out, and this is our final answer. Because a square root of a negative number is undefined, because you can't have, it doesn't have any answers in the real number plane. For example, square root of 4, what this basically means is what number would you square to get positive 4? If you have something like square root of minus 4, you can't square any numbers at all to get a negative number, because when you square a number, you're timesing it by itself, right? And say, for example, minus 2 squared, even when you square a negative number, it's going to give you a positive number. So nothing would like square to give you minus 4. So that's why it's undefined. So that's it. Let's do another example. Cool. So let's use the same logic as last time, as over here. So we do the substitution equation. We gotta write a new equation though for this one specifically. So what would be most appropriate would be to say L equals x cubed now you can say L squared, because L squared equals x to the 3 squared, which is x to the 6. Okay, so L squared minus 8L plus 1 equals 0. L equals and then L will ultimately equal to 4 plus square root of 15, or L equals 4 minus square root of 15. So now we gotta, this is also basically saying 4 plus square root of 15 equals x to the x cubed. So you just do an equation now to get the answer in terms of x. So you can say 4 plus square root of 15. Let's work with this one for now. Equals x cubed. And then it's going to give us a long decimal answer, but yeah, it doesn't matter. So the answer would be cube root of 4 plus square root of 15. So that's our answer for this one. Now let's get this answer in terms of x as well. So x cubed and x would be equal to cube root of all of that. So there you have it, people. So that's it. Let's do one final example. Okay, so now let's try and do like an even crazier on steroids question. So let's start off with the substitution. We'll choose q equals x to the 5. And now we can substitute that over here. So 4q squared plus q minus 1 equals 0. And then solve. So now let's try and solve in terms of x, right? So let's use blue now. So minus 1 plus square root of 17 over 8 would be equal to x to the 5. Let's start off with this one. So let's write that out here. Equals x to the power of 5. And then this is actually pretty simple at this point. All you do is you would do a root 5 to both of them. So x to the 5 is equal to of this whole thing. So minus 1 plus square root of 17 over 8. So now x is equal to, because this simplifies to just x is equal to that. And let's try round it off to 2 decimal places this time, because this form kind of looks untidy in my opinion. So this would be equal to 0.83 approximately. Okay, now let's try and solve for this one. So same thing. Cool, so x is equal to, rounded down to 2 decimal places, minus 0.91. Okay, let's move on to the discriminant now. So the discriminant is basically this b squared minus 4ac over here. So let's just check what all that is about. So we have a quadratic. This is the basic form of the quadratic equation, and let's just investigate the square root, the third thing over here, the b squared minus 4ac. So when b squared minus 4ac is a negative number, it's undefined because the square root of any negative number is undefined. And if b squared minus 4ac results to 0, then there's two equal roots. And that's because when you say minus b plus 0 over 2a, that's the same thing as saying minus b minus 0 all over 2a. So it's identical roots in that case. If you have b squared minus 4ac is greater than 0, you're going to have two different roots because of the plus minus over here. You're going to have, like for example, say b squared minus 4ac is equal to 4. Minus b plus square root of 4 over 2a would be different from minus b minus square root of 4 over 2a. Cool. Let's see what each scenario looks like visually on a graph. So when b squared minus 4ac is greater than 0, is 0, and is negative. So when it's greater than 0, we would have two instances where the graph intercepts with the x-axis, and it would be two unique points, right? So this point here and this point here. And when b squared minus 4ac is equal to 0, we would only have one point where they intercept with each other, where the parabola and the x-axis intercept, right here. And when it's a negative number, then it wouldn't intercept at all. So if you're going to write an equation, x squared plus 12x plus 36 is equal to 0, the only point where that equation is equal to 0 is over here. So that's why you'd only get one unique solution. And in the other case over here, if you say x squared plus 4x minus 12 equals 0, and you solve for x, these would be your solutions. And if you say 2x squared minus 3x plus 4 equals 0, you can't really solve for where that equation is equal to 0, because there's no points over here where they intercept with the x-axis. Okay, let's look at the line of symmetry for a quadratic equation. The general form of the quadratic equation is right here, and the equation for the line of symmetry for all quadratics is y is equal to minus b over 2a, which is basically this vertical line right here. This vertical line is the one that touches the very tip of the quadratic and goes straight up. So you can kind of see that it's the midpoint between this point and this point here, this root and this root here. So let's just check how this equation is derived, minus b over 2a. So these are our two roots, minus b minus and minus b plus, right? And intuitively, this x value here, this x value here would be equal to the average of this and this, because it's in the middle. So let's try and do that to get the x value. So we'll say this over here plus this over 2 to get the average. So okay, so there's the expression we're going to just use. So the sum of the two roots over 2. So that's going to be the midpoint value for x. So let's just simplify this. Minus square root of b squared minus 4ac plus square root of b squared minus 4ac is just 0. So let's just toss that out. So it's minus 2b all over 2a, since it's the same denominator for both of them. And half of that, because we're getting the average. And then it's going to be minus 2b over 4a, which just equals, this is 2 minus b over 2a. So x equals minus b over 2a. That's the basically the x value for the midpoint right here. Let me just go to it. For the midpoint right here. And we know that when y equals a constant, it's just a vertical line. So when y equals minus b over 2a, so this x value over here, that's why it's just like a vertical line going through the midpoint or very tip of the parabola right there. All right, let's look at some simultaneous equations with quadratics. So we have this right here, y equals 3x plus 2 and y equals x squared plus 2. So represented on the graph, it looks something like this. So we want to find the x values where the two diagrams intersect, right? So what we'd have to do is we'd have to equate this y value with this y value. So we'd have to and then after equating it, you just solve for x at this point. So standard quadratic, whatever, you'd move everything to one side. So x squared minus 3x equals 0. And x would just be equal to 0 or 3. To find the y coordinate now, you can sub back the 0 or the 3 into either one of these and work out the value for y. So for example, if I want the y value over here, then I could just sub in 0. I can just sub in 0 to this equation or to this equation. So let's just sub it into this one because it looks simpler. So y equals 3 times by 0 plus 2, which just equals to 2. So right here, this value over here is 2. And we can do the same for 3. If we want to see what the y value over here is, then we can sub in 3 to this one or this one. Let's sub it into this one. So y equals 3 multiplied by 3 plus 2, which just equals to 11. So this value here is 11. So you can equate two equations together to see where they intersect and find the coordinates. Let's do one more example. So we have here y equals 1 plus 2x and y squared equals 2x squared plus x. And we can't exactly equate them right now because over here we have y, while over here there's y squared. So you can't say 1 plus 2x equals 2x squared plus x, because it doesn't. So what you should first do before equating them is you got to square this over here so that you can get y squared over here. And then, because what you do on one side, you do to the other side, and then you can equate the y squared and the y squared. And then let's just simplify this. So 1 plus 2x squared would be equal to 1 plus 4x plus 4x squared. So let's do one more example. So we have here y equals 1 plus 2x and y squared equals 2x squared plus x. And we can't exactly equate them right now because over here we have y, while over here there's y squared. So you can't say 1 plus 2x equals 2x squared plus x, because it doesn't. So what you should first do before equating them is you got to square this over here so that you can get y squared over here. And then, because what you do on one side, you do to the other side, and then you can equate the y squared and the y squared. So and then let's just simplify this. So 1 plus 2x squared would be equal to 1 plus 4x plus 4x squared. So And now let's gather like terms on one side. So x squared minus, that's untidy, x squared minus 3x minus 1 equals 0. And now you just solve for x. So x equals 3 plus minus square root of 13 over 2. So you can just leave it like that, or you can round it down to like 2 decimal places or whatever you want. So that's the final answer. Where let's do one more example. So we have here y equals 1 plus 2x and y squared equals 2x squared plus x. And we can't exactly equate them right now because over here we have y, while over here there's y squared. So you can't say 1 plus 2x equals 2x squared plus x, because it doesn't. So what you should first do before equating them is you got to square this over here, so that you can get y squared over here. And then, because what you do on one side, you do to the other side, and then you can equate the y squared and the y squared. So and then let's just simplify this. So 1 plus 2x squared would be equal to 1 plus 4x plus 4x squared. So two x squared plus x. And then we just bring everything over to one side. So 2x squared plus 3x plus 1 equals 0. And now x equals minus 1 and minus 2. Cool, now that we've covered everything, or at least I think we've covered everything, let's move on to some practice problems. So here's a question, and you should try and do it on your own before we go over the answer. Find the relationship between P and Q if the equation has equal roots. So if we remember about the discriminant, if a quadratic would have equal roots, that means that the discriminant is equal to 0. Because if you say minus b plus 0 over 2a, that's the same thing as saying minus b minus 0 over 2a. So ultimately, you'll get an identical root. So we can use that to form an equation with P and Q exclusively without like x there. So let's see what happens. So we say b squared minus 4ac equals 0, and we just sub in the values representing b, a, and c. So 3q would be b, so 9q squared minus 4, and p is a, and c is 9, equals 0. And we want to find the relationship between q and p, so we're going to move one of them to one side. So let's just simplify this. 9q squared minus 36p equals 0. And now 9q squared equals, oops, I forgot the p, equals 36p. And let's just divide each side by 9, so we can get a clean q squared. Q squared equals 4p. So that's ultimately the relationship between p and q. Right, let's do a question now with inequalities. So minus 6x squared plus 7x plus 20 is greater than or equal to 0. Let's just try and attempt to draw it on a graph, so we can just can kind of imagine what's happening. So it will look nothing like this, I think, but it will have this shape. And now we want the values of x that give a value of greater than or equal to 0. So that means basically the values of x in this area here that give a y value of greater than or equal to 0. That's what we want. So the first step would be to find the critical points or the roots using something like the quadratic equation. Cool, so these are the roots, and it turns out I did completely draw it wrong. This should be shifted a bit more to the left because one of the roots are in the negative plane, but whatever. This is just so we can get an idea of what's happening. So now we want the x values bound between these two critical points because we're looking for this region over here. So the x values between x1 and x2. So that could just be represented as minus 4 over 3 is less than or equal to x. Or is less than or equal to 5 over 2. So that just represents all the x values over here. Right on to the next one. Let's try complete the square on this. So basically put this expression here in this form. So what we do is we'd first of all factor out the coefficient of this x squared term. So let's do that. So that's equal to x squared plus 4x plus 5 over 3. And now we can move on to our next step, which is factorizing this x term over here. So what we do is we want to get, well, let's just express it here. So now when we expand this, we're going to get x squared plus 4x plus 4. So now this is kind of identical to over here, except we don't want that last plus 4. So we're just going to say minus 4 to negate it. And then we just add on this constant here, plus 5 over 3. And then let's simplify this constant. So minus 4 plus 5 over 3 is equal to minus 7 over 3. And now to top it all off, we just multiply 3 by this term over here and this term here. So we can get rid of these extra outer brackets. So 3x plus 2 squared minus 7. That's your final answer for completing the square on this. Right, the next follow-up question for this expression we just completed the square on is find the coordinates of the minimum value. So let's just look down here on this completed square version. Since there is a squared sign over here, that means that whatever is the sum of inside here, whether it be like minus 100 or minus 1, it's going to end up becoming positive because of the squared sign here. Because a minus times minus is positive. So in the very end, when you say a positive number minus a negative number, you're going to end up with a slightly larger number than this, or a much larger number than this negative number here. So the only way to like get the lowest possible value, which is minus 7, would be to make this whole thing inside here equal to 0. So what you do for that is you just say x equals minus 2. Because minus 2 plus 2 is 0, and 3 times 0 is 0, so we're going to end up with minus 7, which is the lowest possible value in this case. Right, so let's try factorize this equation and hence solve for x. So remember how we factorize, we multiply this coefficient with this term over here, So let's first do that. Minus 18. And now we got to try and check which factors of minus 18 would add to give this x coefficient. So which factors of minus 18 would add to give 7. So right away you could tell that it would be minus 2 and 9. So these factors of minus 18 would add to give 7 over here. So now we can just re-express this as 2x squared minus 2x plus 9x minus 9 equals 0. This still simplifies to give 7x, so we haven't really changed anything. And now we just further factorize this. It's much easier to factorize. We put in a much easier to factorize form. So take out the common factors between these two terms and these two terms. So 2x, x minus 1 plus 9, x minus 1 equals 0. And then you just collect this term and this term and x minus 1. So you can say 2x plus 9 x minus 1 equals 0. And then from there you can just solve for x. So you can now say x equals 1 or x equals minus 9 over 2. Right, let's now do a simultaneous equation. And let's try find the coordinates of the points of intersection between this equation and this equation here. So the first step we take would be, for the top one, since that's easier to do, we find an expression for y. So we can say y equals 8 minus 3x. And then that y value, we can use that to work over here with. First of all, we'd want to square this y so that we can be able to sub in the squared result of this expression here into this y squared over here. So y squared is equal to 64 minus 48x plus 9x squared. And now we can sub in that y squared value into this y squared in this equation. So now let's just simplify and collect like terms. So 12x squared minus 48x plus 36, I think, equals 0. And now let's divide everything by 12 to make it simpler. Now all we have to do is solve for x. So x equals 3 or x equals 1. So from there we can now work out the y values, because we're looking for the coordinates, which also includes the y values, obviously. So we could use the equation y equals 8 minus 3x over here. So let's just rewrite that. Y equals 8 minus 3x. So when x equals 3, y would be equal to 8 minus 9, which is minus 1. And when x equals 1, y would be equal to 8 minus 3, which is 5. So that's it. So let's just write the coordinates down. 3 minus 1 and 1, 5. So those are the coordinates of the point of intersection between this line, or rather curve, and this line here. Right, so for this equation or question, we want to find the x values. Well, obviously, that's for all the questions. Okay, so what we first do is we would multiply everything by x to the 4 to get rid of this these horrible denominators. So let's do that. So 8 times x to the 4 is just equal to 8, and 5 over x squared times x to the 4 is just equal to 5x squared. And then 3 times x to the 4 is just 3x to the 4. And now let's just bring everything to one side. Now this looks like a case where we'd use that substitution method that we saw earlier on. So let's do that. Let's say L equals x squared, and then sub in L for wherever we see x squared. So 3L squared minus 5L minus 8 equals 0. And now this is something we're all familiar with. We can just use the quadratic formula for this at this point. So L is going to be equal to 8 over 3 and minus 1. Now, we haven't really finished up over here. We still need to find the x answers, like in terms of x. So now we have to sub in, we have to say, so L equals x squared. Now we're going to have to say 8 over 3 equals x squared, and minus 1 equals x squared, and then solve for x for each one. So let's start with 8 over 3. So 8 over 3 equals x squared, and x is just going to be equal to plus minus the square root of 8 over 3. And now for the minus 1 L value, let's also try to figure out the x answers for that. So minus 1 equals x squared. X would be equal to square root of minus 1, which is just undefined because you can't have a square root of a negative number. So we can just cross that out. So this is our final answer right here.